Okay, they throw a curveball here. It looks like for number 8, they've already we've already isolated the radical, or the radical's already isolated on the left-hand side, but we've got an x on the right-hand side. Once you've isolated the radical, you know what to do, right? You square both sides. So let's do that and see what happens. Well, this square is going to allow me to get rid of my radical. So I'm going to have x squared plus 3 equals, now I've got to square x plus 1. The wrong thing to do would be to just put a square here and a square here. That would be the wrong way of doing that. X plus 1 squared means that I've got to multiply x plus 1 times itself. X plus 1 times x plus 1. Okay. And the way I multiply this out is I multiply the first term with everything in the second parentheses, and then the second term with everything in the second parentheses. So let's do the first term. X times x is going to be x squared. X times 1 is going to be a positive x. And then I do the second term. 1 times x is going to be a positive x. And 1 times 1 is going to be a positive 1. That's going to give me x squared plus x is 2x's plus 1. And what I'm going to have on this side is x squared plus 3. Now, we know that when we have the same thing on both sides of the equal sign with the same sign, we can just cancel whatever is the same. Okay? So now what I have left is 3 equals 2x plus 1. 3 equals 2x plus 1. Okay, now I want to get eventually x by itself, but before I can get x by itself, I've got to get 2x by itself. So I've got to get rid of this positive 1, and since it's positive, I'm going to use the inverse of a positive, which is negative 1. That's going to give me 0 on this side. But what I do to one side, I have to do the other, so I'm going to subtract 1 from this side. That's 3 minus 1 gives me 2. 2 equals 2x. Now, I want to get rid of the 2 so that I can have x by itself. So the way I get rid of the 2 is by using the inverse operation. This is 2 times x, so the inverse of 2 times x would be division. And I'm going to divide by 2. That's going to cancel out. 2 divided by 2 equals 1. 1 times x equals x. And I'm going to divide this side by 2. 2 divided by 2 equals 1. Okay, that's my answer. Okay, again, the radical is isolated already, so I don't have to do anything other than just do the square root. I mean the square. That's going to get rid of my radical, so I've got x divided by 4 equals 3 squared. 3 squared means 3 times 3, right? So 3 squared is 9. Now, I'm going to cross multiply to solve this equation. When I have a fraction on one side, I like to cross multiply to solve. So x times 1 is x, and 4 times 9 is 36. X equals 36. In this problem, the radical is not by itself. It's not isolated yet, so I've got to isolate it. I've got to get it by itself. I've got to get rid of this 6 to do that. This means 6 times the square root of x minus 5, or 6 times radical x minus 5. So since it's multiplication, since the operation being done here is multiplication, I'm going to divide by 6. That's going to give me 6 divided by 6 is 1. 1 times radical x minus 5 is radical x minus 5. But what I do to one side, I have to do to the other. So since I divided this side by 6, I'm going to divide this side by 6. 6 divided by 6 equals 1. Now that I've isolated, to solve my equation, I square both sides. That's going to get rid of this radical. Me squaring this allows me to just remove this radical. What I get is x minus 5. Equals 1 squared, 1 times 1 equals 1.